Hello, welcome back to my channel GateX AIML. Today I will start with the Gate DA syllabus. So in that the first module is probability and statistics. So it has I had divided this into 7 modules as per the syllabus of Gate DA. So the first chapter in this is counting. Probability statistics, one module out of 7 modules in your Gate syllabus for DA. In that the first chapter is counting. Basically in counting we will learn about more about permutations and combinations, which are the basic blocks for your probability theory and further your machine learning and discrete logic structures. So now we'll start with counting. So what is counting? Counting basically we call it as the combinatorics. So we call it as combinatorics. So now so to begin with, let us understand what is combinatorics. What are the key areas in combinatorics? What are its applications? This is just a motivation to learn why I am learning this. Not mandatory like we will get a question from this and all. This is only the basic understanding or a motivation, like why should I learn this? What are its applications? Where I am going to use it? So now let us understand what is this combinatorics mean. Combinatorics is area of mathematics. The area of mathematics which deals with counting, arrangements, and ordering. So basically what I am saying is, you are given some items, you want a specific outcome. Let us say I have given you 10 books. Now we want to arrange them in a specific order. Say the books that belongs to computer science, the books that belongs to mathematics. So to arrange them like this in this order and then keep it in the shelf. For example, if you have seen in your library, college library, anywhere, there you have different sections. Why it is made like that? What is the use? That is a combinatorics, an example of combinatorics. Basically, if you want to specifically get a computer science book in a big library, I need not search it. If I give you some order or some arrangement, if I make some arrangements or in particular order, then easily I can pick that book. So that is solution for finding your books quickly. That is an efficient way. So that is the area of combinators which deals with the counting, arrangements, and ordering of the given items. Now we'll see what are the key areas in combinatorics, where this combinatorics is applied. First one is enumerative combinatorics. This is basically deals with the ways in which the specific configuration can occur. What I mean to say is, let us say I have taken A to Z letters in English, uppercase, all uppercase. Now I want to form 4 character or 4 letter password. 4 letter password from this characters A to Z uppercase. So you can pick any character from A to Z and place it here, 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 and here, right? So there are many number of combinations possible. So this area we call it as enumerative combinatorics, or just simply we call it as counting. That is one area. The next one is permutations and combinations. This is what we will be learning in this syllabus. In depth, permutations and combinations. So more on this I will explain later, and we will solve many problems. So let us start the basic understanding of what is permutation. Permutation is nothing but arrangement. Again, the arrangement of given items or things where order matters. This is important. for example, order matters means what? There are 3 students, say S1, S2 and S3. Okay. Now I can rearrange them, say S2, S1, S3. Okay. There are different possible permutations or arrangements possible. So what it says, the order matter means this permutation is different from this. Okay. They are not equal. That is what it means. When it comes to combinations, it is also arrangements of item where order does not matter. Okay. Say out of 10 students, say I choose 3 students. Okay. So here the students, say I have chosen S2, S4 and S5. Okay. So here the order doesn't matter. I can choose and place like this S5, S4 or S3. See, I had chosen the same 2 same 3 people. Okay. The order does not matter here. Order does not matter. Okay. That is the difference between permutation and combination. Don't worry, we'll be learning and solving at least 100 problems on these both concepts, permutations and combinations later. Okay. The next application area is pigeonhole principle. It's a very widely used principle and a very simple concept. Let us try to understand this. What it says. So, say I have say n items. N items. Then I have say n holes or slots. Okay. So these are the slots. Now, if there are n items and if there are n holes, then I can place one item in each of the holes, right? Okay. So this is what is the basic. Now suppose say that if I give n plus 1 items, okay, and same n holes, now what I can do? I'll keep on placing one item in every hole. Okay. Now there will be one item left at the end. So I have to place it somewhere with other item in one hole. So one hole contain now, in one of the hole contain now 2 items. Okay. So this is the concept of pigeonhole principle. What it says, if I have say greater than n items and n holes, then that means what? At least one hole contains more than one item. That is the concept of pigeonhole principle. Then the next one is inclusion exclusion principle. What is inclusion exclusion principle? Let us say I have 2 sets, set A, okay, and B. So I will only count the number of items in set A and set B. So this indicates number of items in set A, number of items in set B. Now if I want to find A union B, number of items in A union B, okay, how will you write? Okay, you already have the formula, but how you got that formula? Let us draw a Venn diagram. This is set A, okay, and this is set B. This is set A, this is set B. Now set A contains these many items, okay, and set B contains these many items, okay. Now when I take A union B, if you observe here, this is the intersection part. That means what? The elements are counted twice, okay. The elements are counted twice. So how will you get this? Total A plus total B. Now some elements are common in A and B. So this part is common, right? Intersection part. So what I have to do? I have to subtract that. So this is the concept of or principle of inclusion and exclusion. A and B included minus common things are excluded. Okay. Next one is the graph theory. For the computer science background students, you know what is a graph and graph theory. We will define usually graphs in terms of set of vertices, also called as nodes, okay, and then edges connecting the vertices. So let us take a simple graph. Okay, this is a simple graph with 4 vertices or nodes v1, v2, v3, v4. Let us say this is the edge 1. E1 connects between v1, v2. Okay, E2 connects between v1, v4. E3 connects between v2, v3, and E4 connects between v4, v3. Okay, so what is the counting here? Okay, if I take as this set, okay, so let us take the vertices v1, v2, v3, v4. Here v1, v2, v3, and v4. So what is the edge connecting between v1, v2? v1 to v2, there is edge e1. This is a combination. So this counting principle of combinatorics is applied for finding the pairs of relations pairs. Okay. Next is the partition theory. What the partition theory says is very simple thing. Non-overlapping items. Okay. So let us say that I have taken 8, integer 8. Now I can write it as 3 plus 5. Okay. Okay, I can write it as 1 plus 7. So these are the different ways. If you observe here, these two are unique, okay, non-overlapping. So basically, in probability theory, we may require this, the partition theory, where we will be using the Bayes theorem. Okay, what exactly it says? If this is the entire sample space, this is the entire, say it's a set, universal set. Okay, we'll explain in probability theory what is samples, space, events, and all those things. Let us partition this non-overlapping. That means this is set 1 or partition 1. This is partition 2. This is partition 3. This is partition 4. Partition 5. You observe that they are all overlapping, not non-overlapping. Okay. If I want to get the entire set, yes, so it is nothing but sum of all these partition. This is called as partition theory. So what is combinatorics here applied here? Where it is applied means, see this sets, this is one example. The same can be divided into say 7 partitions, okay, like this, non-overlapping. 1, 2, 3, 7. So now this is a different combination, but still we'll get the same sample spaces. This is the concept of partition theory, where in the Bayes rule or Bayes theorem we'll see it again. Okay. Then one more application is generating functions. The generating functions basically helps to encode the mathematical equations. For examples, if you have learnt algorithm subjects in computer science, okay, or any mathematical, discrete mathematics or basic mathematics, you may have learnt it. For example, say that I want to find time complexity given the equation Tn, and it is recurrence, that is Tn minus 1 plus 1, for example. Okay. So this is a generating function. So using this, you can go on generating like Tn minus 2 plus 1, okay, plus this one. Like that, you go on generating, finally will arrive at some final value. So these kind of functions are called as generating function. Okay. Now we'll see some of the applications of combinatorics. Applications in the sense real world applications where they are used. Basically, they are specifically used in computer algorithms. So most of your algorithms are based on what? The permutations and combinations, how you solve the problem. So this also includes what? Your machine learning algorithms, your AI algorithm, all those, or your basic algorithms as well. And the most important of this is cryptography. and network security. You learned this subject in your BTech or any other degrees. You learned it. You learn different combinations like using the keys RSA, DES, AES, and all those. This is nothing but combination of different numbers, okay, and how you encode them. Okay, and it is also used in data structures. Okay, these are all computer related, I'm telling. Then very important thing currently in the market, game theory. Okay. Then you have the probability theory. And many more. For example, other than computer science, you have bioinformatics. Bioinformatics is a very demanding field now. So, for example, here you want to find the DNA sequence, is match the DNA of persons. So, it's the DNA sequencing. These are some of the vastly used real world applications of combinatorics. Now, finally, we'll come to our permutations and combinations. From here, we'll start actual syllabus. So, whatever we have learned till now is just the motivation to start why I am learning this concepts. Now, we'll understand what is permutation, what is the combinations, and then we'll start solving the problem. So, now let us try to understand what I mean by permutations. Permutations is, again, I told you, arrangement of items where order matters. Okay. So we are choosing or we are arranging R items from given n items. So we write it as NPR. Okay, arranging R items from n items. P is stands for permutation or. So so there are different notations in different textbooks. Okay, this is, or you can write like this: P n comma R. So the formula is, I will not go for the derivation of this. Okay, if you are interested, you can just search in Google or any AI tools that will give how it is derived. Okay, this is the formula for permutations. Now let us understand what is this n factorial. The n factorials, this is also written in some textbooks like this. Okay, both are same, the exclamatory mark or factorial symbol. So this is given as n into n minus 1 into n minus 2 till you go up to 1. Okay, this is how we calculate the factorial of n. For example, factorial of 5 is equal to 5 into, next 5 minus 1 is 4, 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1. So we stop at 1. So this will give you 120. So we calculate the factorial. So this is for permutations. Now similarly, to go for combinations, combinations is also arrangement of items where order does not matter. Okay, so we say usually choosing R items from n items is given as NCR. Okay, it is also written as like this, NR. Okay, this brackets we usually call as binom symbol. Okay, or you can also write as C given n comma R. Okay, this is nothing but n factorial divided by, okay, n minus R factorial into R factorial. Okay, this is the formula for your NCR. Okay, so we'll try to solve more problems. There are some more rules for identifying, okay, whether when to apply sum rule, when to apply product rule, when to apply division rule, when to apply subtraction rule. That we will see in the next class. So thank you for listening. So we will start with the rules for identifying permutations and combination, and when to apply sum rule, product rule, division rule, and subtraction rule in the next video. Please like, subscribe, and share my channel. Thank you.